So we were looking at structures and how we dynamically allocate them. And namely, we had the example where we had this struct, my struct, and it had two members, an integer called int member, and a short called short member. And so we were talking about how can we dynamically allocate this and access the members, because now we have the problem that we have a memory address and we have to first dereference it and then access the members, and this can be quite complex. So really what we're going to quickly do is really do the code examples that I showed in the lectures and create a dynamic structure and then access the members, and also show how, for instance, you could pass in a structure to a function in a couple of different ways. So we have here now we want to create a struct, my struct pointer, and so we're going to so we need the full type, my struct, and call it my struct pointer. Now we'll use malloc to allocate this. So we want a size of struct, my struct, and then we'll just do some error checking. If my struct pointer equals null, return. Now, why is this complaining? Yes, it's complaining because I haven't typecasted it, and this is always dependent on your compiler version. Struct my struct. That's my struct pointer. So there we go. Because I forgot the asterisks. Okay, so this should now build implicit declaration, and I've forgotten to include standard lib. And so now, if this all works out, we will have had we'll have a structure allocated in memory, and we can look at my struct pointer, and so this will just show us a memory address as it does. But if we dereference, we print a dereference of it, we'll see here we have the structure in memory, and luckily enough we've got zeroed out values, but this is not guaranteed. So because I've used malloc, it's not guaranteed to be zero, but we can guarantee this is going to be zero by using, for instance, the function memset. And if we look at memset, it takes in void, a pointer to where the value to set and the size of things to set. So what it's going to do is going to fill n bytes in memory with the constant byte and which is pointed to by s. And so for us, that means that we want to say memset my struct pointer, and we want to put in zeros, and we're going to say size of struct my struct. Sorry, struct. So this will guarantee that it's always going to be zero depending on whatever, and because we're not using hard-coded values, for instance like 6 here, we can add things to our structure and all of this code will sort of adjust, right? So after this point, we now know we have an allocated and zeroed out structure. So we can then access the members, and let's say we want to set the integer value to like 2, then we can do this two different ways. So firstly, we know that we have this pointer to this memory region where a structure is stored. So if we want to go to the memory address and look at the structure, we have to dereference it. So therefore we have to go my struct pointer. And now at this point in time, like after writing this, we have dereferenced the memory address. These brackets, what's inside of these brackets is for all intents and purposes a structure that can now be accessed with the dot operator. And so if we use the dot, my handy little auto completion will tell me, hey, we have two members that we can access. So we can say int member equals 2, right? And so this is completely valid. But then we're also talking about that when you're accessing structures through pointers, that this is a bit cumbersome, this whole access method. So we can actually use the arrow operator that C implements, which is quite a bit easier. So we can just do arrow, and then we can see we can access the short member. We can set him to equal, for instance, 5. And so these both do the same thing, well obviously on different members, but the this one here is a lot simpler, and I think it's a lot easier to understand, because this, when you're doing large complex lines of code, can be very hard to sort of check what's doing and where. So now if we run this, warning implicit declaration of memset. So memset is in string. I forgot again. And so now we can break on 23, and I'll print my struct. I've got to run first, run, and print my struct pointer. And we'll see here that the members have been set, right? And so we can then use these sort of accessors or accessors to set and get values of structures. And so this is handy because then we can use structures like we would any other variable. We can pass them into functions as pointers and have them modified within the function, and then once the function returns, it's still valid. You can pass in a structure as a parameter and then return a structure. Like we could make a function that has the type struct my struct and takes in, or let's say, increment int member, and then it'll take in a struct my struct. And for instance, then it can say, so we'll take return, and we'll have to firstly say struct my struct return equals my struct. Well, actually, no, I think the easy way of doing this would even be to say my struct, because this is the actual int member. Oh man, I'm just not doing well here. So I'll say foo, so we'll give it actually a name now, and say int member plus plus, and then we can, because this is local on the stack, we'll actually return this one, so return foo. And so if we were to then, for instance, do this here and say increment int member, we could then pass in a dereferenced my struct pointer. So this is the same as saying go to the memory address and get me the structure. Now this would increment the value, and it's returning a structure, so we can actually save this somewhere. So we can say struct my struct temp or static structure equals, and when we know, because this is returning a structure, my struct, that we can save this statically like this, right? Quit, yes, no. And now, for instance, if we look, we'll stop at line 28 and we'll go into this function. Now we can see that foo is a structure, and it has the same foo, and then what would we call the other one? We called it my struct pointer, which I can't get in the current context. It's not a global. We see here then we can increment foo, and then we return foo, and if we look in static structure, we'll see the same thing. When we look inside of my struct pointer, oops, we'll see that it hasn't been modified, because we used, what we did here is we dereferenced structure. So we essentially said, hey, take my actual structure, and it copied it into the function on the stack. And we know that these variables are created, like copied. And so even though we've passed in a dereferenced copy of my struct pointer here, it was copied, and therefore this modified return version didn't actually affect the original pointer, right? So that is a useful way of using structures. We can either return them, or for instance, we could make another structure that returns, or another function that returns void increment short member, and here we'll do it, then we'll take a struct, my struct pointer, and we'll call that foo, and all we have to do is go foo short member plus plus. But now the difference is it's not actually taking in a copy or anything and returning a new copy. It's just taking a memory address and it's going to go and directly modify that memory address. So here we can now take, for instance, increment short member, and we'll pass in the address of our newly created static structure. And then we can see if we debug this, oops. So we'll go down to 34, and we'll see here that static structure, go on more further. Static structure. We'll see that we have 3 and 5 on the short member, and now since we're going to pass in, we can look at the address of static member. We see it's at 900, and if we step into increment short member, we can look at foo, and we'll see that it's the same address. And so what's happening here using this arrow accessor, it's just going to this 900 address where we know static structure is stored. It's accessing the short member and it's incrementing it. And so then if we just step out of this function, we can now see that static structure now has a short member value of 6. So we're good. So hopefully this helps to understand quite quickly how structures can be used dynamically with pointers, and just in general the power of pointers when they're used correctly.